Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is the 3.1, 3.2 mixed notes. This is all review from the last couple of lessons that we have done, so we will probably go through this fairly quickly. When you give 4 examples of a monomial, remember a monomial is going to be a polynomial that does not have an addition or subtraction sign. So 4 examples would be 3, 3x, 3xy, 3x squared, y squared, z. 2 examples of a binomial. Binomial is going to have 2 monomials that are added or subtracted together. So 3 plus 3x, 3x plus y, 3x squared plus 7. Trinomial will have 3 monomials, all added or subtracted together. So 3x squared plus 6x plus 9. X cubed plus x squared plus x. And a polynomial is going to be anything that has 4 or more monomials that are added or subtracted together. So 2x to the 4th, 5x to the 3rd, negative x squared plus 7x, 3x to the 4th plus 6x to the 3rd, plus 9x squared minus x minus 27. Both of those are just polynomials. Alright, so now we need to find the degree of each polynomial. The first thing we want to do is go ahead and put this in standard form. Looking at the first problem, are we in standard form? Yes, we are, because the largest degree is to the front. We got to remember that the largest degree is going to be the degree of our polynomial. So this would be the second degree. This would be a 0 degree. This would be a 5th degree, and this would be a 1st degree. It's the largest exponent that I have in the problem. All right. On to naming polynomials. There are 2 different ways. They are completely unrelated. One we can name by the degree. The other part of the name is going to be named by the terms. So a 1st degree polynomial, well, a 0 degree polynomial is always a constant. That's like 27 in the example above. Degree 1 is going to be linear. Degree 2 is quadratic. 3 would be cubic. 4 would be quartic. 5 would be quintic. You really need to memorize these guys. On to naming by the number of terms. 1 term would be a monomial. If you have mono, you have to be by yourself. 1 person, mono. Okay. 2 terms would be a binomial. Think about a bicycle. Bi being 2 wheels. Binomial, 2 terms. 3 terms would be a trinomial. Tricycle, 3 wheels. 3 terms. More than 3 terms, so 4 or more is going to be a polynomial. There's no special name for something that has 4 or more terms. All right. On to the next section. Write in standard form. Identify the leading coefficient, the degree, the number of terms, and classify the polynomial. So here we got to write it in standard form. We want to make sure that our largest exponent goes first. That means that if I have a variable and I don't have a variable, like problem 5 where I have 4 minus 5x, the variable would always come first. So I'd have negative 5x plus 4. The signs that are in front of each term will stay with the term. Okay, now we need to identify the leading coefficient. That would be negative 5. My degree would be 1. The number of terms would be 2. So the name would be what? It's going to be a linear binomial. On to 6. Is that in standard form yet? No, it's not, but 3x squared will be in front. I have 6x would be the next largest exponent, minus 4. Now I can say the leading coefficient is 3. The degree is 2. The number of terms is 3. So the name would be a quadratic because I have the second degree. Trinomial because I have 3 terms. Negative 34 is already in standard form, so we don't have to write anything there. The leading coefficient here would be negative 34. The degree would be 0. The number of terms would be 1, so the name would be a constant monomial. If you think about it, I could never have anything that would be like a constant binomial, trinomial, polynomial, because if they're all constants, then we would have to combine like terms, and in that case, it would always end up being a constant monomial. On to number 8, our largest exponent is going to be this negative 2x to the third. X squared would come second, 4x would come third, and 6 would come last. So leading coefficient's negative 2. The degree is 3. The number of terms is 4. And the name would be a cubic polynomial. All right, on to the back. Here we need to perform the indicated operation, then classify the polynomial. Remember, if there is an addition or subtraction sign in between the two sets of parentheses, it will not be multiplication. We are not going to distribute. What we will do, though, is take a positive 1 and distribute it to everything in the second set of parentheses, which means that all the signs will stay the same. I also have a positive 1 to distribute in the first set of parentheses. So what I'm going to end up, 1 times 5x squared would be 5x squared. 1 times 3x would be 3x. 1 times negative 2 would be negative 2. Okay? Then 1 times 3x squared would be positive 3x squared. 1 times negative 2 is negative 2. 1 times negative 4x to the third is negative 4x to the third. Now, we need to go ahead and find our largest exponent. Well, our largest exponent is going to be this negative, or it's going to be x to the third. So my first term will be negative 4x to the third. There's nothing else that can go with that. So that would be our first term in our polynomial. Our next largest would be 5x squared. Is there another x squared? Yes, there is. It's 3x squared. So 5x squared plus 3x squared would be 8x squared. Get rid of the x squareds. Next thing we're going to look at is there an x? There is an x. It is positive 3x. Right here. Is there another x up there with it? There's not, so it'd be positive 3x. Finally, we have a negative 2 and a negative 2. Those would combine to get me negative 4. Now I can go ahead and say that my leading coefficient is negative 4. My degree is 3. My number of terms is 4. So the name would be a cubic polynomial. On to number 10. Again, I have a positive in between, so really what I'm going to do is I'm going to do the same thing I did on 9, but instead of actually writing those ones in and drawing all the arrows and everything else, I'm just going to drop the parentheses because if you ever distribute a positive 1, it just keeps all the signs the same. So it'll be 3x squared minus 2x plus 1 minus x plus x squared minus 5. Okay? We need to look for our largest degree, which is 2. Our largest degree is 2. I have a 3x squared. Is there another x squared? Yes, there is. It's positive x squared. So 3x squared plus x squared would be 4x squared. Those are done. Now I'm going to look for an x. I have negative 2x, and I have negative x. Well, negative 2x minus x would be negative 3x. Then I have a positive 1 and a negative 5. 1 minus 5 would get me negative 4. Okay, so our leading coefficient then would be 4. Our degree would be 2. The number of terms would be 3. So the name would be a quadratic because it's the second degree, trinomial because I have 3 terms. On to 11. Number 11 is a little bit different. I have a negative in between. When I have a negative in between, I'm going to take a 1 out front of each. This 1 times 5x would get me 5x. 1 times negative 3x squared would get me negative 3x squared. 1 times positive 8 would get me positive 8. Now, negative 1 times negative 6x squared would be positive 6x squared. Negative 1 times negative 4x would be positive 4x. And negative 1 times positive 5 would get me negative 5. All right? So again, we're going to do the exact same process as far as combining like terms. I'm looking for our largest degree. Our largest degree is 2. It's the x squareds. I have negative 3x squared and positive 6x squared. So negative 3x squared plus 6x squared would get me 3x squared. Get rid of those. I have 5x and 4x, so that would get me positive 9x. Then I have 8 minus 5, which would get me positive 3. So the leading coefficient then would be 3. The degree would be 2. The number would be 3. And the name would be a quadratic trinomial. All right. On to number 12, same thing. I'm going to add a 1 in front and a 1 between the negative and the parenthesis. 1 times negative 2x to the third is negative 2x to the third. 1 times 5x squared would be positive 5x squared. 1 times negative x would be negative x. And 1 times negative 4 would be negative 4. Negative 1 times negative 2x to the third, positive 2x to the third. Negative 1 times negative 6x squared would be positive 6x squared. Negative 1 times 12 would be negative 12. Again, I need to find my largest degree. My largest degree in this case would be x to the third. Since I have a negative 2x to the third and a positive 2x to the third, those are just going to cancel out right away. Negative 2 plus 2 would be 0. 0 times anything is just 0, right? So then I have 5x squared and 6x squared. Well, 5x squared plus 6x squared would get me 11x squared. Then I have this negative x. There's no other x's up there with it. Now I have negative 4 minus 12, which would be negative 16. And I'm done there. So my leading coefficient is 11. My degree is 2. My number of terms is 3. And the name is a quadratic trinomial. On to number 13. Number 13, all I need to do is to distribute the negative 3t squared into everything inside the parentheses. So negative 3t squared times 3t squared would be negative 9t to the fourth. Negative 3t squared times negative 4t would be positive 12t to the third. Negative 3t squared times 5 would be negative 15t squared. What's my leading coefficient? Negative 9. My degree is 4. The number of terms is 3. So the name is a quartic. Think of a quarter. Trinomial. On to 14. We're going to use double distribution or FOIL here. So x times x, it is x squared. X times 3 is 3x. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. I need to combine like terms. So x squared, there's no other x squared up there. So that just comes down by itself. Then I have 3x minus 5x, which would be negative 2x minus 15. And I am done. It is in standard form. So my leading coefficient would be 1. My degree would be 2. The number of terms would be 3. And the name would be a quadratic trinomial. All right. 15. Remember from our last section, if I have a binomial times a trinomial, I need to multiply everything in the first set of parentheses by everything in the second set of parentheses. So I'm going to take x squared times x squared, which would be x to the fourth. X squared times negative 3x, which would be negative 3x to the third. X squared times 2 would be positive 2x squared. And I have 3 times x squared, which would be positive 3x squared. 3 times negative 3x would be negative 9x. And 3 times 2 would be positive 6. From here, I need to combine like terms if I have any. X to the fourth, there are no other x to the fourths, so that can just come down. Negative 3x to the third, there are no other x to the thirds up here, so it'll be negative 3x to the third. I have positive 2x and positive 3x squared. So it would be positive 5x squared, negative 9x, and 6. It is done at this point, so my leading coefficient would be 1. My degree would be 4. The number of terms, whoops, I don't want to use n for that. The number of terms would be 1, 2, 3, 4, 5. So the name would be a quartic. Again, think of a quarter there. Polynomial. Okay? On to 16, everything in the first set of parentheses times everything in the second set of parentheses. I'm not going to use arrows here because it gets a little sloppy. So it would be x squared times x squared, which would get me x to the 4th. X squared times 4x would get me positive 4x to the 3rd. X squared times negative 5 would get me negative 5x squared. So I'm done with that x squared now. Okay? Now I have negative 4x times x squared. Negative 4x times x squared, negative 4x to the 3rd. Negative 4x times 4x would get me negative 16x squared. Negative 4x times negative 5 would get me positive 20x. So I am now done with the negative 4x. I'm going to drop this down one line. Hopefully, while you're working on a normal piece of paper, you can write this all on one big line. Unfortunately, up here on the board, I cannot. So now I'm going to take 2 times x squared, which would be positive 2x squared. I'm going to take 2 times positive 4x, which would be positive 8x. 2 times negative 5 would be negative 10. Again, I need to combine like terms, so I'm looking for my largest degree. My largest degree is the 4th degree. There is only one 4th degree, that is x to the 4th. So I'm going to go ahead and write that down. The next largest would be x to the 3rd, or my 3rd degree. My 3rd degree, I have a positive 4x and a negative 4x to the 3rd. So those are just going to cancel out. Now I have a negative 5x squared, a negative 16x squared, and a positive 2x squared. Well, negative 5 minus 16 would be negative 21. Negative 21 plus 2 would get me negative 19x squared. Okay? Then I have positive 20x and positive 8x. Those would combine to get me positive 28x. Then I have a negative 10. So my leading coefficient would be 1. My degree would be 4. The number of terms would be 4. And my name would be a quartic polynomial. That is the end of our lesson. The biggest thing you have to remember here is how we go ahead and perform the indicated operations. If I have an addition or a subtraction in between my parentheses, then I will not distribute. It's not a multiplication problem. Okay? If I have the parentheses butted right up to each other, then it is double distribution, or we just need to remember to multiply everything in the first set of parentheses by everything in the second set of parentheses. Then the other biggest thing you need to remember here is how to classify by degree and by the number of terms. Thank you very much for watching the video. Remember, if you have any questions, to bring them in to me, and have a great day.